Hello, guys. Welcome back to Engineering Trends and Innovation, where we explore the cutting edge of engineering and technologies that are shaping our future. I am your host, Alimami Conte, and in today's episode, we are talking about a topic I have been personally excited about since I was in undergrad, which is quantum computing. We are going to unpack what it is and why it matters to us, and where the technology in is today and how it could completely reshape engineering, science, security, and our society. Let us start with the basic traditional computers. These Let us take the one example: your phone, your laptop, or even supercomputers. All use bits to process our information. A bit is either a zero or a one in numbers. Quantum computers, on the other hand, uses qubits. And here is the twist about it. A qubit can be zero or one or both at the same time. This is called superposition. Then we have entanglement, a property where two qubits become linked, so changing one affect the other, even across distances. And finally, quantum interference, which helps guide calculations, meaning that solving complex mathematical calculation towards the correct answers by canceling out the wrong ones. So, together, these properties allow quantum computers to process information in parallel on a scale that is, let's say, nearly impossible with classical computers. But here is the important part: quantum computers don't just do things faster, they do things that we humans can't. Now, you might be wondering, where does this apply in real life? So, let's look at few engineering challenges that quantum computing could transform. Number one, material design. So, as a mechanical design engineer, um, I have get a first hand of spending time on simulating new alloys, or example superconductors, where quantum computers could analyze the interaction at atomic molecules or level in seconds. Second point is drug discovery. But the molecules are quantum systems. Quantum computers can model them precisely, unlocking cures faster, cheaper, and more reliable than ever. So the third point I'm going to emphasize on is optimization of problems, meaning that creating solutions to our problems. So let us think about logistics for delivering fleets, air traffic controls, or electrical grids. Classical computers can only estimate. Quantum computing could find the absolute best solutions to our challenges or problem we are facing. That is why optimization comes in. So the fourth point is cryptography. And today's internet security relies on mathematical problems that are hard for normal computers to solve, like factoring huge numbers. Um, a fully developed quantum computer could break this in minutes. Excited. And that brings us to the flip side, which is the risk. And in this channel, we don't only talk about the advantages, we talk about disadvantage and how it is linked towards our daily life. Quantum computing could break the backbone of digital security, which is a crucial part of our today's society: security. So most encryption systems today, like the RSA, the ECC, and even blockchain related algorithm, rely on problems that are computationally hard for classical machines. Quantum algorithm like Shaw's algorithm could solve them exponentially faster. That means encrypted emails, financial transaction, meaning that sending cash from one point to another, even classified government communication are currently vulnerable. So to prepare, engineers are already developing post quantum cryptography, meaning that to secure our systems, new encryption method resistant to quantum attacks. But we are in a race between the tech and protecting against it, meaning that we are designing and also creating a security system to help that design sustain. So, in corporation, in defense, and the national governments are watching this closely. It is not a matter of if, it is when we will be exploring deep into quantum computing. So, where we are with the real world quantum computers. So, we are diving now into the real side of it. Right now, the companies like IBM, Google, Intel, Rigetti are leading the charge in quantum hardware. IBM has a roadmap to build like 100,000 qubit machines by 2030. Google claims to have reached the quantum supremacy, meaning their quantum computers solve a problem no classical computers could do in a reasonable time. So your gaming machine cannot solve it in a reasonable time, but quantum computer, Google are claiming that. But today's machines are still noisy. They are quite extreme. They require extremely cold temperature. They produce errors. This is called the NISQ, which is a noisy intermediate scale quantum. A transitional phase between or before we get to fault tolerant system. So I want us all to think of it like in the early 1950s in classical computing, vacuum tubes, massive rooms, limited functionalities. That is where we are now. So still progress is rapid. And as engineers, we need to prepare. To be honest, we really do need to prepare. If you are a student, a young engineer, or even a company looking to future proof your work, this is the time to get involved. Quantum computing will need hardwares, engineers to build the system, software engineers or software developers to create the quantum algorithm, theoretical scientists to explore the new models and design the new models. And also, don't forget about ethics and policy experts to guide the responsible deployment of this technology. That is why you're seeing the US Senate, they are having a lot of ethics and policy guidelines. So basically, you don't need to be a physicist to contribute towards this field. Mechanical engineers, electrical engineers, and software engineers are playing key roles when it comes to quantum computing. The world will need cross-disciplinary skill sets of all sets of the STEM field to support this technology. Quantum computing is one of the most exciting field. I think I can recall watching a movie on that, and it is also intimidating. It is the frontier in engineering today, and it has the potential to solve problems we have never been able to crack. It's, it can crack complex problems, man. But it is also forces us to rethink the security, ethics, and also how we interact with the information itself. It is not a science fiction anymore. It is happening currently. As you heard that Google are boasting of that, So engineers like us will need to be part of this conversation and not just reacting, but also leading. So this brings me to the end of this episode where I discuss about quantum computing. And thanks for listening to this episode of Engineering Trends and Innovation. If this topic sparked your curiosity, share it with friend, colleague, or students who need to hear about quantum computing. And please don't think that this channel is only for engineers or scientists. If you're using technology, please subscribe to this channel. And if you are a company or an institution looking to partner with our platform, let us talk on the chat side. We are building a community of thinkers, builders, leaders that are ready for the next era of innovation. Until next time, keep exploring, keep questioning, and keep engineering the future of technology. This is Engineering Trend and Innovation, where we explore the cutting edge of engineering and technologies that are shaping our future. I am your host again, Alimami Conte, and please like, subscribe, and share with your community. Thank you very much.